How many have heard the word perpendicular before? Good. You should have. Perpendicular. If I've got a line, I'll call it line L. And then I'm going to draw a line perpendicular to it. How do I need to draw it?
Oh, right at the
No, middle has actually nothing to do with it. Right, just you draw it so it makes a perfect plus, you could say, right?
yeah.
Say this line in. Now, what that means in geometry, it means that when they intersect, they form a special kind of angle, which is what?
Right.
Which is how many degrees?
90.
So actually, when two lines are perpendicular, how many 90-degree angles are actually formed?
4.
This one's 90, this one's 90, and this one's 90, right? You got 4 90-degree angles. L is perpendicular to N. Now, if you'll remember, I've talked about mathematicians, the people who made geometry. They're lazy. They don't like to write out a bunch of stuff. We don't like to write out a bunch of words. They're probably going to have a symbol for this, aren't they?
Yeah, upside down T.
It's an upside down T. And why do you think we write it like that? Because it kind of looks like they form what kind of angle? Right angle, right? She's not here today. Huh?
What's her name?
Joy?
Joy? Okay.
Do you need to take this back or?
What?
Okay. So L is perpendicular to N. As you can see, it looks like two right angles here, doesn't it? The upside down T. So we're going to expect you to know what that means. So when someone says that, they're saying to you it creates what kind of angles? 90-degree angles. And if you remember, we've talked about, complementary angles and things like that. So, guess what?
What? What?
The only other thing really in this section, believe it or not, look at Theorem 3.9. Let's see if we can read this and understand what it's saying. It is on page 131. It says, if a line M is in a plane, and we'll call it, is in a plane, and point T is a point on M, there exists exactly one line in that plane that is perpendicular to M at point T. That was a mouthful, huh? So first, let's draw line M on this piece of paper. Okay, that's the first thing. Line M is in a plane. What else is in this that they're saying to me? Line M is in a plane. So this piece of paper I just drew it on, is that not the plane it's in? Okay. What else did they say? And T is a point on M. So now I need to draw some point we'll call what? T. Actually, I wish I hadn't put my T right there. What is this theorem saying? Is this exactly one line in this plane that is perpendicular to M at T? Think about it, there's only one way on this piece of paper to draw a line that would be exactly perpendicular, wouldn't it? Look at my rule. But this, basically the edge of this ruler represents a line, doesn't it? You know, if I drew this line like this, yeah, that'd be a line going through T, but would it be exactly perpendicular to the line? If I move it a little bit, still not, but then I get to a point maybe right there where guess what? That line's what? Perpendicular. So I make my line. But as I move, what happens? It's not what? So there is only what? One line that I can draw through that, that's what? Now, why did they have to say in this plane? Look at my pencil up here. Could I not come from top exactly in here and make a perpendicular from a different plane? But they're just talking about in this plane.
For parent-teacher conferences.
Okay, thank you very much. Okay, any questions there? Does that make sense? How there's only one line that can be drawn through any point that's perpendicular to a line? Okay. Let's get our worksheets out. Okay, let's go over what they give us here. Maybe use this green highlighter here. First, they say that AG, before I even start worrying about answering number one, I need to decipher everything that's in this, about this picture, and the conditions. AG is perpendicular to CE. AG, where's A? Right there. Where's G? G is perpendicular to what? CE. So it would be good for me to put that in right there, wouldn't it? Would you agree?
Could you put it over like the D too, or does it matter?
It doesn't matter. But remember, it creates what? 4 right angles, right?
Alright.
So this is a right angle, that's a right angle, and that's a right angle. Okay, AC is perpendicular to what? BF? They already put it in there for you, didn't they? But we could highlight over just to say, okay. And point B is the midpoint of AC. And point B is the midpoint of AC. This is a typo. Does anyone know why? Any point is in the middle of a line because it goes on forever and ever. This is supposed to say what? Segment AC. Okay? So they basically say B is right in between A and C, so that length is equal to what? These two are congruent. Determine whether the following are true or false. So I've written down all my stuff. Now, if you guys want to do more, you know that this is what? 90 degrees, that's 90 degrees, this is what? That's what? This is what? 90 degrees, this one's 90 degrees, that whole thing there is 90 degrees, and this whole thing here is what? 90 degrees. Angle 1 is a right angle, or angle 1 is congruent to angle CBD. C to B to D. Is that true? Are these two congruent?
Yeah.
They're true. They're congruent for a couple of reasons. Anytime look up here, anytime two lines intersect, what do I know about the opposite angles? They're congruent, aren't they? So these are because they're vertical angles. These two are congruent because they're vertical angles. Are also congruent because we just stated they're all 90, didn't we? So what's the answer here? All right, angle 1 is a right angle. Is angle 1 a right angle? What does it mean to be a right angle? It means it's what? And is angle 1 90 degrees? So that's what? Angle 2 and angle 3 are complementary. What does it mean for angles to be complementary? They add to what? All right, go up here and let's look at angle 2. That's right here. And angle 3. Do they add to 90 degrees? One, there's nothing here that tells you that. But that together they make what kind of line? Straight line. So what do you know here to here is? So actually, this is what? False, because this should say what? Supplementary, shouldn't it? Okay, on to number 4. Angle GDF plus the measure of angle FDE should equal 90. First, where's GDF? G to D to F. So we're talking about this angle right here, right? And FDE, and this angle right here. Should they add to 90? They're the two smaller parts that make up this whole angle that we have already stated is what? So what's the answer here? True. Angle 1 should be congruent to angle 5. Well, here's angle 1. Where's angle 5? We know angle 5 is 90. We know angle 1's 90. Does that mean they're congruent? Yes, they're the same measure. AC is the only line perpendicular to BF. Okay, let's go A to C. A to C is the only line perpendicular to BF at B. Well, didn't we just learn they are perpendicular, and is there only one line that can be perpendicular to a line at a point? It's only possible to be one, so the answer here is angle 3 is an acute angle. Angle 3, is that acute? No. Angle 1 is congruent to angle 2. Here's angle 1, there's angle 2. Are they congruent? No, there's nothing that says that they are, so we got to say false here. Angle 2 is congruent to angle 6. Are these two congruent? Why? Angle 2. Is this congruent to this? That's the thing. They look like they are, don't they? Would everyone agree with that? Eyes up here, please. The angle 2 looks like it should be congruent to angle 6, doesn't it? But there's got to be more than it looks like it. Is there a theorem that says anything about this situation we have? Move over to the right. Did I just talk about it? Yeah. Anytime two lines intersect, what do we know about the opposite angles? Are these two lines intersecting? Yep. Are 2 and 6 opposite angles? Therefore, they are vertical angles. Therefore, they have to be congruent, so it is what? True. AG is perpendicular to DE. A to G is perpendicular to D to E. What do you think? Would these lines be perpendicular? Yeah. Name 4 right angles. Well, angle 5 is 1. What else? Angle 1. And then after that, we got to start naming them, don't we? Angle, what'd you say? CDG. Very good. She went C to D to G. That is a right angle. We need one more. Angle C to D to A. Is that what you said? Yeah, we could do that too. Or we could have gone C to B to D, right? There's a lot of them up there, but they just asked for 4, and that's an example of 4. Name a pair of supplementary angles. That means angles that add to 180 degrees. Are there a lot of angles that we could use here? All these 90-degree angles right beside each other, they're supplementary, aren't they? These two are supplementary. These two. What about 2 and 3? They're not right angles, but are they supplementary? Angle 2 and angle 3. If measure angle 3 is 120, measure of angle 3 is 120. Find the measure of angle 2. What's angle 2 got to be then? Very good. Which angle is complementary to FDE? F to D to E. GDF. Right? That was actually up here in the top, wasn't it? It's kind of the second time we've dealt with those. Measured angle 6 is 45. What's the measure of angle 2? Okay, if the measure angle 6 is 45, what's the measure of angle 2? 45. Not so bad, huh? Now, you'll probably have a set of problems like this on your homework, won't you? You think I expect to be a nice, big, drawn, especially since you're going to have 2 days to do this? Nice, big, pretty, and I say big, figure drawn? Yes, I expect to see that on your paper. Do you think, when I say write the problems, do you think I need to see just true here? No, write that out. That's not that hard. It doesn't take you that long. I'm asking for an extra 10 minutes of your life, maybe 15. If it's a really hard assignment, I might be asking for 20. That's a sitcom. Come on, people. It's not that bad. Okay? We always need to, and you know, it's not just to be mean that I do that. You always need to be taking into effect what the problem is. Too many, and it's also to combat those people who just want to go and write answers down and copy from the person next to them, and they're not learning anything. I would like you to learn something. That's the point of school. It's not just to torture you. It is to learn something. Okay? Sometimes that gets lost